So to graph our parabola, let's have our vertex, which is the HK, and for the parabola, the vertex is your center. Let's have the vertex be at the origin, okay, to start us out. So let's draw an origin point right there. That's our vertex. I'll put a V right here. Yes?
Which one are we doing?
This is the parabola. Okay? Yeah, we're going to do the horizontal one. So this is the HK, also known for this graph as 0, 0. Now let's draw a parabola here. Now, I'm not going to make it exact. It doesn't have to be perfect. This is a horizontal parabola. And right here is where you guys find your focus. Let's see. That's right there. We'll just make a focus point right there. That's F. Now, if this is HK, F can be found by taking P and adding it to the H. You guys remember seeing the formula? Some of you guys are like, "What's that P?" Well, that's the P. So this function, this equation, I should say, it's not a function, would look like this. Because it's horizontal, the side that has the 4P, that one has the X. And minus H is always with the X. So this one has the 4P times X minus H, because it's horizontal. The other side is going to be y minus k, because minus k is always with the y, squared. Now for this graph, we know that h, k are both zeros, and so you could write your function like this. I'm sorry, not function, stop saying that. You could write your equation like this, y squared equals 4p times x, because the h and the k are both 0 in this case. Alright, so now you know, hopefully, it makes sense, that this distance right here is the p, which is why we would go h plus p, because h is your horizontal movement. That's your x. Now there's one more word here that you need to know, and that's called directrix. The directrix is the opposite side of p, or of the focus, but it's the same distance. So they need to be the same distance. In fact, that's what makes the parabola. This is actually kind of interesting. The reason why we have a focus point and a directrix is because the focus point and the directrix are equal distances from every point on this parabola. Now, my picture is not perfect, so it doesn't look like it, but every point on this parabola should be an equal distance from the focus point and the directrix. The directrix for this problem can be found by taking P and subtracting it from which number? The H or the K?
H.
Yeah, from the H, because we're moving left and right, so we're going to subtract it from the H. And because this line is vertical, it's X equals, and we're going to say H minus P. And those are the formulas that are on the slideshow that I just showed you guys. Okay, so this is on your formula sheet. You guys can copy this graph on your formula sheet, or what's that? Now, how do you know that this is a horizontal parabola? We know because the x is with the p and the y is being squared. That's how we know it's horizontal. Okay, well, how do we find the p? Well, I'd have to have a specific problem to show you guys how to find the p, but we're going to use this formula to find the p. The P, if it's positive, goes to the right for the focus. If the P was negative, then we would go left for the focus. And so that's how we know it would go the other way.
And then is that the way the parabola would be?
Yep, that's the way the parabola always wraps around the focus. So if, let's see, if I get a big eraser right here. If we didn't have this directrix right here, let's just get rid of all this. Let's say our vertex is right here. We're not at the center anymore, but then our focus point is negative. The P is negative, so I have to go to the left because the P is negative. And this is my focus point. That means my parabola is going to wrap around that way. So it opens up to the left instead of the right.